Hello friends, in this video we are going to start with a brand new chapter that is event handling. This is our new chapter and this is very interesting chapter. This chapter examines an important aspect of Java, that is the event. Okay, so everything is related to event in this case. Event handling is a fundamental to Java programming because it is a general, it's integral to the creation of many kinds of application. Okay, so first of all, it is interactive interactive with user. So it is fundamental to Java programming. It is a core of Java programming. For example, any program that uses a graphical user interface such as Java application written for Windows is event driven. So event is everything like press event, text, edit text event, or mouse press event like this. Okay, so it is very interesting and it is very interactive with user. So it is most widely used in Java and it is core of Java programming. You cannot write this type of programs without a solid command of event handling. So you have to understand it better. Events are supported by number of packages including java.util, java.awt and java.awt.event. So you have to import this type of packages if you want to understand and use event handling. Beginning with Java 9, Java AWT and Java.awt event are part of the desktop module, Java desktop module, and Java.util is a part of Java.main base module. Many events to which program will respond are generated when user interacts with the GUI based program. Okay. Multiple types of event to which your program will respond are generated when user will be interactive with the GUI based program. So that graphical user interface may contain a text, may contain a keyboard, may contain an image, and so on. These are the types of events we will see in this chapter. They are passed to your program with variety of ways with a specific method dependent upon the actual event. There are several types of events, including those generated by the mouse, the keyboard, the various GUI controls such as push button, scroll bar, or checkbox. Okay, so depending upon the GUI you are using, the events will be different. This chapter will begin with overview of Java's event handling mechanism, and then we will examine a number of event classes and interfaces used by AWT. AWT was Java's first GUI framework and it offers a simple way to present a basics of event handling. Okay, so we will start with first what is event handling and how it is achieved with the abstract window toolkit. Then chapter develops various examples that demonstrate the fundamentals of event processing. This chapter also introduces key concepts related to GUI programming and explains how to use adapter classes, inner classes, and anonymous inner classes to streamline event handling code. Okay, so several key concepts or basic guidelines related to graphical user interface programming will be introduced over here, and also how to use the adapter class, how to use inner class, and how to use the anonymous inner classes to streamline event handling code. Now the examples we will provide in the remainder of this course made frequent of these techniques. This chapter focuses on event related to GUI based programs which has the text box, buttons, etc. etc. However, events are also occasionally used for purposes not directly related to GUI. In all cases, same basic event handling techniques may apply. Okay, so not every time GUI will be there. Okay, it may be there or it may not be there. So in all cases, same basic event handling techniques that we are going to learn over here apply. Okay. We will see now two event handling mechanisms. Before beginning our discussion, an important historical point must be made, that is, the way in which the events are handled changed significantly between the original version of Java and all subsequent versions after 1.1. Okay, so way we were handling the event handling were significantly different. Okay, in Java, original version of Java 1.0 and all subsequent Java versions after all with Java 1.1. 1.0 method of Java event handling is still there. We can still use it, and it is not recommended or may are also many of the methods that support old 1.0 event model have been deprecated. Okay, the modern approach is the way that events should be handled by all new programs, and thus is the method employed by programs in this book. Okay, so new approach we are going to start here is the way that events should be handled by all new programs, and thus is the method employed by programs in this course. Okay, the 1.0. Next, the delegation event model. The modern approach to handling event is based on the delegation event model, which defines standard and consistent mechanisms to generate and process event. Okay, so first of all, this delegation event model will generate the events and then they will process the events. Okay, so next, its concept is quite simple. A source generate an event and send it to one or more listener. So first, to handle an event, first it should be generated. So source will generate an event and next we send it to one or more listener. In this scheme, the listener simply waits until it receives that event. Okay. Once the event is received by listener, the listener processes that event and then returns. The advantage of this is that application logic that processes events is cleanly separated from the user interface logic that generates those events. Okay, so generator is different and processor is different of the event. So it is cleanly separated and it is very much easy to understand. A user interface is able to delegate the processing of event to separate piece of code. Okay, user interface element like a button, an image is able to delegate the processing of event to a separate piece of code. In the delegation event model, listeners must register with the source in order to receive an event notification. Okay. First of all, listener must register with the source so that it should be able to receive the event notification. Notifications are sold only to listeners that want to receive them. Okay, so not all listeners will receive the notification of event. Only the listeners, those are interested that some event is happening, some event is coming, only those will receive the notification. This is a more efficient way to handle. In short, those listeners who have registered with the sender, those only will only have the notification of event, not all of them. This is the more efficient way to handle events than the design used by original Java 1.0 approach, in which event was propagated up the containment hierarchy until it was handled by a component. Okay. So it is a more efficient way to handle events than the design used by original Java 1.0 old approach. Okay, so what was there in old approach? Event was propagated up the containment hierarchy until it was handled by a component. This required components to receive events that they did not process and it wasted valuable time. Okay, so all was used to receive the notification, and all was not interested at that time in the Java 1.0 model, and it wasted the valuable time. Okay, so here in this case, only those are interested, only interested listeners will have the notification. Delegation event model eliminates this overhead regarding the time complexity. Following sections will define those define events and describe the roles of sources and listeners. Okay? Events. In the delegation model, an event is an object that describes the state change in a source. So something has been happened. Like this, button has been pressed. Image has been pressed. Text has been entered. Text has been changed. Radio button has been changed. Checkbox has been checked. Like this, those are called as an those are treated as an object that describe that something has been changed, something state has been changed in a source. Okay, so what is the state? Like first time the state of checkbox was unchecked, and after user is doing something over there, state of checkbox begs the check. Okay, so there is a state change of the checkbox. Among other causes, an event can be generated as a consequence of a person interacting with the elements in a graphical user interface. Okay, so event can also be generated as a consequence interacting with the elements as in a graphical user interface. Some of the activities that cause events to be generated are pressing a button, entering a character via keyboard, selecting an item, clicking the mouse. Many other user operations could also be treated as examples. Okay, events may also occur that they are not directly caused by interaction with the user interface. So like I have already explained in the last PPT, may graphical user interface may or may not be there all the time. For example, event may be generated when the timer expires, a counter exceeds a value, or software or hardware failure occurs, or operation is completed. Okay, like a timer expiring, counter exceeding a value, software or hardware failure, or an operation is completed. Any operation like download operation is completed. All this stuff does not include graphical user interface. Here also some event is occurring. You are free to define events that are appropriate for your application, for your needs. Okay, so you can define your own events. Event sources. A source is an object that generates an event. Okay. This occurs when the internal state of that object changes in some way. Okay. So source is an object, any object that generates an event. This occurs when the internal state of that object changes in some way. Sources can generate more than one type of event at the same time. Source must register listener in order to listener receive the notification. Those are interested about a specific type of event. Each type of event has its own registration method. Here is the general form: add type listener, L. Okay. So each type of event has its own registration method available. Type is the name of event. Here is a reference to the event listener. Okay. So each type of event is there that will be passed over here, and the reference to the event listener is provided. The method that registers a keyboard event listener is called add key listener. Okay. So here it will be like public void add key listener EL. Okay. The method that registers a mouse motion listener is called as add mouse motion listener. When an event occurs, all registered listeners are notified and receive a copy of the event object. This is known as multicasting the event. Okay. Okay. When an event occurs, all registered listeners are notified and receive a copy of the event object. This is known as multicasting the event. In all cases, notifications are sent only to listeners that registered to receive the event. Those are interested. Some sources may allow only one listener to register. Okay. Whenever an event occurs, all the registered listeners will notify the notification, receive a copy of that particular object. It is known as multicasting the event. Okay. And some sources allow only one register at a time, one listener to register at a time. General form is public void add type listener, to Java or too many listeners exception. Okay, so only one listener will be registered in this case. Type is the name of event. Here is the reference to event listener. When such an event occurs, registered listener is notified and is called as because to the event, unlike the previous method. This is the previous method. Public void add type listener. This can have multiple listeners at a time. Okay. A source must also provide a method that allows the listener to unregister an interest in a specific type of event. Okay. source have to provide a method that allows the listener to unregister an interest in a specific type of event. Okay, so listener is no more interested now to handle the notification, to have the notification, so it can unregister easily. Remove type listener EL, like remove key listener EL, like this. Like type is the name of event, EL is a reference to event listener. For example, to remove a keyboard listener, you would call remove listener. The methods that add or remove listeners are provided by source that generate the event. For example, component, which is a top level class defined by the AWT, provides methods to add and remove keyboard and mouse event listeners. Okay. Like component is a top level class defined by the AWT and provides methods to add and remove keyboard and mouse event listener. So event listener, BDC listener is an object that is notified when an event occurs. It has two major requirements. First, it must have been registered with one or more sources to receive notifications if it is interested about specific types of events. Second, it must implement methods to receive and process these notifications. Okay, it is not only sufficient that it is interested. If it is getting notified about that particular event, it should be also capable of processing that event. So it must implement methods to receive as well as process these notifications. In other words, it should also supply the event handlers, that is processor. The methods that receive and process these events are defined in a set of interfaces, and those are found in java.awt.event. Okay. For example, the mouse motion listener interface defines two methods to receive notifications when the mouse is dragged or moved. Okay. So what should be done in that case? It is also provided in that particular method. When mouse is dragged, what should I do? When mouse is moved, what should I do? And so on. Any object may handle one or both of these events if it provides an implementation of this interface. Okay. Any object may handle one of or both of these events if it provides an implementation of this interface. Whoever that implements the interface, mouse motion listener, can handle this type of mouse motion event. Other listener interfaces are discussed later after this chapter and other chapter. It is the one more important thing. Event handler must return quickly. Okay, so user should not be waiting, and in this case, for the most part, GUI program should not enter mode of operation in which it maintains control for an extended period. Like user is clicking the button and user is waiting. Even if something is happening over there, and user is waiting and so on. This should not happen. Event handler must return quickly. Okay. Instead, it must perform specific actions in response to events and then return control to runtime system. Failure to do this can cause your program to appear sluggish or even non-responsive because user do not wait more than a second. Okay. If your program needs to perform a repetitive task such as scrolling a banner, it must do so by starting a separate thread, like we have seen in the previous session. Moving banner, we have seen that is from left to right to left. Okay. When your program, and in that case, we were creating a separate thread. In this case, we were implementing a runnable interface, and plus we were creating a separate thread for moving. When your program receives an event, must process it immediately and then return. Okay. Event classes. That classes that represent events are at the core of Java's event handling mechanism. Okay. So actually when event is occurring, what should be done? That is written in the event classes. There's a discussion of event handling must begin with the event classes. Those will actually handle the events. It is important to understand that Java defines several types of event and that not all event classes can be discussed over here. So there are so many class types of events and so many classes are not discussed over here. Only important are discussed. Arguably, the most widely used events at the time of this writing are those defined by the AWT and those defined by the swing. Okay, the most widely used events we are discussing over here, those defined by AWT and swing. This chapter focuses on AWT events and swing specific events are discussed in the chapter 32 when swing is understood or explained. At the root of Java event classes is the event object class, which is in java.util package. So what you have to input is java.util.event object. It is the superclass of all events and it has one constructor event object source. Source is the object that generates the particular event. Event object have two methods, get source and toString. Get source returns the source of the event, who generated that event, and its form is object get source, and toString returns the string equivalent of the event. The class AWT event defined within the java.awt package subclass of event object. Okay, so AWT event extends java.awt.event object. You have to remember this. It is a superclass either indirectly or indirectly of all AWT based events used by the delegation event model. Its getID method can be used to determine the type of the event. So if you want to find out which type of event has been occurred right now, you will get its ID using getID method and it will be in the integer format, integer getID. We won't use the features defined by AWT event directly. We will only package that, import that package class event object. Rather, you will use its subclass. At this point, it is important that all of the other classes discussed in this section are subclasses of the AWT event. It is for the sake of understanding only. Event object, first of all, we will take in short. Event object is a superclass of all events. AWT event is a superclass of all AWT events that are handled by delegation event model. The package java.awt.event defines many types of events that are generated by various user interface elements. Okay. Table 25.1 shows several common used event classes and provides a brief description of when they are generated. Okay. So the upcoming table we will going to see several commonly used event classes plus when they are generated, its brief description. And package java.awt.event defines many types of events that are generated by various user interface elements. Commonly used constructors and methods in each class are described in the following sections. Action event class. An action event is generated when a button is pressed, a list item is double clicked, or a menu item is selected. Okay. What is action? If particular action is performed. Action event it is generated when a button is pressed, list item is double clicked, or a menu item is selected. Action event class defines 4 integer constants that can be used to identify any modifiers associated with the action event. Alt mask, control mask, meta mask, shift mask. And in addition, there is an integer constant action performed which can be used to identify action event. It has 3 constructors: action event object source integer type string command, action event object source integer type string command integer modifiers, action event object source integer type string command long wait integer modifiers. Okay, so these are the methods. Action event class generated when button is pressed, list item is double clicked, or menu item is selected. Adjustment event generated when a scroll bar is manipulated. Component event generated when a component is hidden, moved, resized, or becomes visible. Okay. A container event generated when a component is added to or removed from a container. Focus event generated when a component changes or loses input focus. Input event abstract superclass for all component input event classes. Item event generated when a checkbox or list item is clicked. also occurs when a choice selection is made or a checkable menu item is selected or deselected. Event generated when input is received from the keyboard. Mouse event is generated when the mouse is dragged, moved, click, press, release, or also generated when the mouse just enters or exits the component. Mouse wheel event generated when the mouse wheel is moved. Text event is generated when the value of text area or text width is changed. Window event is generated when a window is activated, closed, deactivated, de-iconified, open, or quit. Okay, so this way we have seen some important things related to event handling. In the next theory session, we will see more interesting topics, more interesting classes and interfaces regarding event handling, and we will proceed with how event handling is operated or actually handled. Okay, so meet you in the next session with a new theory part. Till then, you can enjoy event handling process. Thank you so much.